Oh, okay. So, hi everyone. So, welcome you all in our course Data Analysis using RProgramming. And today we are on the session number 8 and we are discussing about the data structure. And in our previous class, we have discussed about data structure, and the first data structure we had covered, and which is vector. Okay, so as I told in our previous class, like a vector is just a single dimensional data storage medium. Okay, so when you are having a single variable, so you can store a single variable data in a one data structure which is called as vector. Okay, so how you can imagine, so like for example, suppose if you are collecting the age of the people, like for example in our class peoples, like we are here, and if I ask everyone's their age, okay, so you will tell me some numbers, and if I wanted to store that particular number in a variable, then this variable will be called as vector. Okay, so what we are seeing here, we are just capturing the data in a single person single record. Okay, single thing is there. So in this is called as one dimensional data structure, right? And the most important thing what you need to keep in your mind is that whenever you are storing your data in a vector format, right, so vector is just to hold a single data type of values. What it mean by single data type, so like for example, whatever the data you are having, all those data will be of same type. Like for example, age. Okay, so all this vector will only include the age. If you are capturing the gender of the peoples, right, so the whole vector will include the gender of the people particularly, right? So it means that vector is a data structure which is capturing the data of single dimension and homogeneous, or you can say a uni data type values. Okay, so now let me tell you how you can imagine this part. Okay, so like for example, suppose if you are just capturing the age of the people or maybe marks of the people, right? So suppose if you ask, tell me about your marks, right? So people will tell that I got 75 marks, someone will tell that I got 85 marks, someone will tell that 83 marks, someone will tell that 90 marks, someone will tell that 91 marks, right? So if you store this particular marks data in a some variable, okay, so let's suppose this is the variable, then this is called as vector. Okay, so you saw here the property that vector is nothing but a unidimensional. Okay, unidimensional. What it mean by unidimensional, it means that it is only going into horizontal way. Okay, with this one, and this is moving in this way, right? This is not moving downward, or maybe this is not a tabular type of data, right? This is having only a single row, right? This is called as unidimensional data, as well as this is uni data type. Okay, so what it mean by uni data type, it means that in this particular data structure, we are just storing the single type of values. Each and every value whatever you are seeing here, this will be of numeric type, right? So you can create a categorical vector, okay, or you can say you can create a character vector, right? Or maybe you can create a string vector as well, right? For example, the list of fruits, okay, maybe list of vector of grains, okay, vector of food items, right? So anything you can create in the vector format, but you should to keep in your mind that this is a unidimensional, so a single data variable can be captured only over here, right? Now how this will be stored into the memory. Okay, so as I told in our previous classes, memory is nothing but a block. Okay, a block in our kind of some hardware, right? So it's a block, and this block is divided into number of cells. Okay, these blocks are just divided into number of cells, right? So whenever you are running your program, let's suppose if you run this particular program, okay, so it means that you are creating a variable called as marks. Okay, so mark variable will be created. Then how it will be stored into the memory, so it will look like in this way, like mark, and these values will be stored like 75 and 85, okay, and 83 and 90 and 91. Okay, similarly you will have multiple values in that way. Okay, so whatever the marks you will ask from other peoples, this will be stored over here, right? So in that way this value will be stored. Now since this is nothing but a memory locations, this is nothing but a memory location, right? This is memory location. So in general this is in the form of some address values, right? This is in the form of some address values, but in address value is not easy to remember, because address values comes up with, like for example, maybe it's a 10 digit address values, like for example your home address. Okay, someone's home address may be like for example A1 180, right? uh, in a particular city, in a particular area, in a particular colony, right? Someone address looks like in this way. Okay, maybe many of yours maybe address it will look like in this way, but this is the memory address is not in this way. Okay, memory address look like for example maybe in a 6 digit format, like for example x a 137 z. Okay, 1. Okay, maybe this is the memory location. So this is not easy to remember. Okay, this is not easy to recall. Okay, because this is a big digit number. Okay, it's a alphanumeric number. This is not easy to recall. So what our platform is doing basically, right? So R is just modifying this particular address and named it as a index. Okay, and they start calling that the first value will be called as the first position value, second position can be accessed, which is the second position value. Okay, so in this way they have indexed all the position. Okay, this is basically the position values, right? So each and every values, whatever the values you are seeing over here, okay, these values are nothing but on a some specific location, right? This is the first position, this is the second position, this is the third position, fourth position, fifth position, in that way. And this is the total number of length is there. So let's suppose there is a n values, so this will be the nth position, right? So this is called as index value, right? So this will be stored into the memory in this way and can be accessed from the memory to just play a role into a program. Okay, you need to call these things using this particular index value, right? So for example, if I ask you just extract the first value from this particular vector, right? So what you will do here, so you will just call the vector. Okay, and just for calling the particular element, what you need to do, you need to use a square bracket, right? And pass the index value corresponding here. So like for example, the first value if you wanted to extract from this particular data, okay, you need to pass the value here, mark 1, and this will give you back as 75, right? So in that way you will access the element from this particular vector, right? Remember, this is the very important concept, okay, just to move ahead for different types of data structure which is coming. Okay, so up to this point everything is clear to everyone, or if anyone have any question or any doubt, so please please clear your doubt over here, because the next data structure will be the updated version of this particular data structure. Yeah, please Richard, go ahead.
Please. So it means that R sees the first value for the vector as 1, or maybe you have to rename it as 1,
Yes.
or R sees it as 1.
Yes, yes. So if you pass over here means this particular address is binded up with this one. Okay. The another position value will be, let's suppose, x a 137 z a and maybe 2. Okay. So this position value will not able to remember. Okay. Every time, right? Memorize. So just make it as 2. So it is just making each and every cell value as their positions. Okay. This is the first position. This is the second position. This is the nth position. In that way R is actually doing inside. Okay.
All right, all right. Can you also, maybe you want to disprove what R is saying, naming it 1 like that way, but you can also choose to say, so start the first value from 0. Can you do that?
Yeah, so but yeah, this is basically, this is depend on the platform, right? Which type of platform we are using. So our platform is basically start their index value with index is equal to 1. Okay, this is the fixed value, right? So in general, like in other programming, if I'm talking about C programming, okay, or maybe the Python programming, okay, so they are using index starting from 0. Okay, this can be, but in R the index value will always be start from 1 and goes up to the length of this particular vector size. Okay, so this is the fixed part.
All right. Thank you very
Okay,
much.
perfect. So if everything is clear up to this point, let's move to the another data structure which is called as, maybe I'll not tell the name, you please tell me. Okay, okay, perfect. So if I ask you a very good question, okay, to everyone, and please try to answer this question. Okay, so let's suppose if you are just clicking a selfie, okay, if you are clicking a selfie in your phone, okay, or just clicking a photo, okay. So you are seeing that your photo, okay, and your photo will look like in this way, okay. Don't bother, okay, this is maybe the someone's photo, okay, sorry for that, just joking. Okay, so perfect, let's suppose this is the photo of yours, someone's of you, okay. So tell me, okay, so if you know that the concept of image, right? You know the concept of image. Image is nothing but a collection of pixels, okay. Image is nothing but a collection of pixels, right? Pixels. And pixel is nothing but a numeric values, okay. Pixel is nothing but a numeric values, okay, because you know that there is a color combination is there which is called as R, G and B, okay, which is called as R is for red, okay. Red is having their own combinations, and G is having their own combination. G is just R is for red, okay, and G is for green, and B is for blue, okay. So these are the three colors, okay, and using these three colors all types of color are being generated, okay. So these are the basic building block of the colors, right? So these values is spending from 0 to 127, 0 to 127 and 0 to 127, right? So these are the different color combinations. So if you mix up the color combination, red is having there is a 127 intensities, okay. Similarly, this particular green is also having there some intensities, and blue is also having there some intensities. And if you are mixing up some small amount of this, some small amount of this, small amount of this, you are forming a new color, okay. Maybe you are including this R as 2, G as 2, B is 2, you are having some different kind of color, okay. So every time whatever the color you are seeing, okay, so these color are nothing but a mathematical value, okay. These mathematical values are coming, okay, and these mathematical value basically comes up from the pixel concept, okay. So this pixel concept maybe I'll cover in our next session, or if anyone is more interested to learn about this concept I can tell you, but this is not that much related to our concept, okay. My point is that let's suppose this image you are seeing, okay. So first thing, tell me how many dimensions you are seeing into this image.
Two dimensions.
Two dimension, perfect, okay. You are seeing here the two dimensional image, right? And just for my curious question, if you zoom this image, okay, in general when you are zooming this image, okay, up in your phone, okay, what you are seeing after zooming the things, sometimes maybe you see some square is coming, right? So your whole image is nothing but a combination of different squares, okay, different squares, and these blocks are basically storing some different types of colors, okay. So like for example, your photo is forming, okay, your photo is forming, just that let's suppose here is the green color is threaded, here is the green color is threaded, in that way in this particular area some color is threaded and your image is being formed, okay, your image is being formed in that way. So this is the basic concept of image formation, right? So here what you are seeing basically, you are seeing that since as I told that each color is having their own mathematical value, okay, each color is having their own mathematical value, it means that every place, every single cell, okay, each and every single cell is having some numeric value, okay, each and every cell is having their own some different type of values, okay. Let's suppose this value is having value like 7340, okay. Similarly this value is having, let's suppose this value is having let's suppose 12738 in that way, and this particular cell is having some other values, okay. In that way all those numeric value is being stored in two dimensional way, okay. So where you saw in the mathematics, okay, where you saw that, where you saw that there's a two dimension and the value, mathematical value is being stored into this particular thing, okay. So if you know, this is called as matrix, okay. So in the matrix you are storing the numerical values or in general values, but in two dimensional, okay. So now another data structure came into the picture which is called as matrix data structure, right? So now what is the matrix data structure? Firstly, the data structure which is of two dimensional, okay, which is of two dimensional, right? So why it is needed? Firstly, let me tell you why it is needed. So you saw that in our previous class we were covering about vector, and vector was only one dimensional data structure, right? But sometimes you are not only capturing the one dimensional data structure, you are capturing multi-dimensional data structure. Okay, so at that time, like for example image. Okay, you saw image. So if you wanted to store the data of your image, okay, you need to store the data into two-dimensional data structure, right? So just to store the image, okay, what you need to do, you need to create another data structure apart from the vector, okay, which will store the two-dimensional data values, right? Another concept is that this is also a uni data type values, any data type values, right? So this is called as matrix data structure, right? How it will look like? So it will look like for example in this way, okay, and this will be in the different cells, okay. This will be look like in a different cells, and each cell will have their own values, right? And this is called as first row, okay. This is called as first row, and this is called as first column, okay. Remember, this is called as first row, and this is called as first column, right? And this is called as nth row, okay, nth row, and this is called as nth column, okay, nth column, right? So now, so this is the way how a matrix will look like, okay, perfect. Now if I ask you, tell me the value which let's suppose here is the value is being stored, let's suppose 23. So 23 is on which position? This is on the second row, okay. This is on the second row. Remember, this is the core concept of this particular data structure, remember. So 23 is in the second row, and this is in the second column, this is in the second column, right? So as you saw in our previous class, okay, so like for example we were creating a vector like 23, 24, 27, 37, 38, right? So this 23 was only the first location, right? Here is the only one dimension, so you were only access the element like for example a and 1. In that way you were accessing. But in the matrix, right, matrix you need to give the in which row this element is and in which column this element is. It means that now you will not give only one index value, you will give the two index values, okay. First, the first index value will tell you about the number which row, and the second index value will tell you about the which column, right? In that way you will able to access the elements, okay. So this is all about the matrix data structure, okay. So how you will get this? So let's suppose if you wanted to start the value 23, then what you need to do, you will call the second row and second position. In that way you will specify, then only you will able to access the 23. Let's suppose if I ask you where is the 45. So where is the 45? 1, 2, 3, 4. This is the fourth row. Okay, this is the fourth row. 1, 2, 3, 4, 5. This is the fifth column. So 45 is at which place? This is on the 44th and fifth place, right? Similarly, if I ask you 38, okay, 38 is at which place? This is on third row, and this is the fourth column. Okay, so this is on third, 3 and fourth place, third number row and fourth number column, okay. In that way you will able to access those element, okay. So this is up to this point. Anyone have any question or any doubt? Please ask, so that I can move to the core programming part of this particular
Hello.
matrix.
Hello.
Yeah, please.
Hello.
Yeah, please go ahead.
So when you actually look at the differences between matrices and vectors, like mathematically, vectors are matrices, except that they have just a single column or a single row based on how you put it. So R is basically considering anything as a matrix if it's only either 2 by 2, 2 by 3, 3 by 2, or any other stuff, because vectors are actually matrices, but R does not consider vectors as matrices. Is that so?
Okay, very good question, Ibrahim. Yeah, for sure. As you are telling that, yeah, matrix is the actually there is a one more very good data structure which is called as array. Okay, so everything is deduced from array. Okay, so like for example, array is basically of any dimensional data structure. Similarly, what the array, what the vector you are seeing, this is also a matrix. Okay, this is also a matrix. If you imagine, right, this is also a one matrix, but this matrix is having only one row, okay. So this is a matrix like for example the dimension is 1 into 1 2 3 4, 1:4 size, right? And this matrix will be of n cross n size. Okay, matrix can be of any size. Let's suppose two rows and three columns, three rows, two columns. Okay, whatever the size it can be, right? So master data structure is nothing array. Okay, so array is actually when it reduced into two dimension, then this is called as matrix. When array is reduced into one dimension, then this is giving you vector, right? So if I just break it down into two ways, if it is divided into two, this is of n dimensional data structure, right? This is array is basically n dimension data structure. Okay, and when it is best kind of a take up to two dimension, then this is called as matrix. Okay, but if it is called as one dimension, right, so this is called as array. Oh, sorry, this is called as vector, right? So these all are just derivation of array part, right? So we are moving one by one. So we first saw that vector. Okay, and vector can be of any type: vector of element, vector of maybe vector of numeric values, vector of double values, vector of character values, vector of string values. Similarly, matrix is also, this is also a two-dimensional data structure, as well as this is a unit data type values. It may be matrix of mathematical values or numerical values. It may be the matrix of maybe character values or maybe st string values, right? So in that way you can specify this part. Okay, Ibrahim, it is clear?
Yes, yes, it's clear.
Yeah,
Except that
yeah,
except that that means that basically they all come from array. So it is the R software that has basically created a clear differentiation between the R and then the vector. So basically, in as much as they are all matrices by definition, R makes a clear differentiation by separating matrices from vectors, right?
yeah. I'm coming to that part. Okay, so up to this point, if everyone's doubt is clear, so let me move towards the programming part. Okay. Okay, perfect. So let me move, and please confirm if you able to see my R Studio screen. Okay, so can anyone confirm whether my screen is visible to you, where I'm just showing you the programming part?
Yes.
Okay, perfect. So again, if you remember in our from the previous class, okay, when I start talking about particular any kind of data structure, okay, so in general in the data structure, as you saw, we can perform we will perform many operations. Okay, so for the first and important thing of any of the data structure is how you will create that particular part. Okay, so how you will create that particular data structure. So like for example, creation means like for example you create a vector. Okay, you create a vector, right? So first part is that creation of the data structure, right? First thing is this one. Now second part is that how you will insert the values. Okay, and the third part is that navigation. Okay, and the fourth part is that updation, and the fifth part is that how you will delete. Okay, so these are the major things we are performing into any of the data structure, right? So let me start covering about how you will create the matrix, right? So matrix can be of any ways. Okay, can be created into multiple ways. As you saw, vector can be created into multiple ways. Similarly, matrix can also be created into multiple ways. So the first way of creating the matrix is using using matrix function. Okay, using matrix function. And the second way of creating the matrix is using rbind rbind function. Okay, and third is using cbind function. Okay, so these are the three methods how you can create the matrix. Okay, let me explore one by one and you will understand the concept, right? So firstly, how you will create the matrix. Okay, so the first part is that we can create the matrix using matrix function. Okay, so there is a matrix function, so let me write the syntax for matrix function, right? So it will be right like for example matrix. Okay, and in the matrix firstly you will pass the data. Okay, so what data you will pass? You will pass any, like for example any data vector. Okay, any data vector you can pass. Okay, but the important thing you need to keep in your mind is that we need to specify the number of rows of in this particular matrix. Okay, which is calling the number of rows, right? Similarly, you will have n call. You need to specify number of column into this particular matrix. Okay, so it will specify number of columns. Okay, columns. Similarly, you need to specify by row. Okay, by row is equal to true and false. Okay, I'll tell you about this particular part. Okay, and maybe sometimes you can also give a number called dim names, option called as dim names. Okay, so dim names will specify as a list part. Okay, so this is the common syntax we are using just for creating a matrix. Okay, so let me create a matrix. Okay, so how I will create, let me show you. Let's suppose a variable name I had created called as mat. Okay, and I will use the matrix function. Okay, I just write the matrix function. Let me pass a data set over here. Okay, so data is equal to, maybe I will create a vector like for example 1 to 9. Okay, 1 to 9. So 1 to 9 is basically a data values. Okay, which is coming from 1 2 3 4 5 6 7 8 and 9. Okay, so 9 values are there. So I will specify this, and n row I will specify. Okay, n row is equal to 3 I will specify, and n call I will specify as 3. So it will create a matrix of 2 dimension which is having 3 rows and 3 columns. Okay, let me run it, and let me run it. See here, a matrix has been created. Okay, this is of 2 dimension, and this is having the element like 1 2 3 4 5 6 7 8 9. Okay, so in that way this matrix has been created. You can pass any type of data over here. Okay, so maybe you can pass your manual data. Okay, whatever the data you are having, let's suppose 23 24 25 26 27 28. Okay, 27 28 and 29 and 30. Okay, you can create this data. Okay, sorry, 3 3 3 6 and one value is left 31, right? So you can create in this way. You can create any matrix in this way, right? Now a big problem is that, let's suppose whatever the vector you are passing over here, right? So this vector is having value 23 24 25, but here the value is coming like 23 here, 24 is here, 25 is here, right? So I want this value here to here. Okay, means 23 24 and 25. It means that whatever the value data values I am passing, I want the values by row. Okay, means firstly complete row will be filled, then it will move to the second row, then again second row will be filled, then rest of the value will go into the third row. Okay, so there is a one more important parameter are specify need to specify, which is called as by row. Okay, so by row is having two types of values. One is true value, one is false value. So if you specify by row is equal to true, it means that whatever the values you specified over here, so it will create one row. Okay, which will be of length 3. Okay, then it will create the second row which will be of again size 3. Then it will be created a third row. Okay, so it will store all the values by row only, right? So currently you are seeing, it is called as by row is equal to false. Now it is coming as by column, right? So whatever the values you are specifying, it is firstly filling first column, then it is moving to the second column, then it is moving to the third column. Okay, but I want this into the row wise, so I will specify by row is equal to true over here, right? See here, right? So if you compare these two matrices, right, so what the things you are showing different, like for example these values is coming like a column wise, and these values are looking like as a row wise. Okay, so this is the way how you can create a matrix, right? Now, so let's suppose I wanted to pass the, like for example here if you see, now column names is coming in this way and row names is coming in this way. Okay, you can rename those. How you can rename it? Okay, so there is a multiple ways. Based on that you can rename it. So like for example you can specify row names. Okay, row names of mat. Okay, you specify row names and mat. You can specify the names. Okay, you will create a names vector. So names vector will be of size 3, because here total number of rows is how many? 3 rows are there, right? So row names will be also 3 only. Okay, so maybe I can give the name like row R1. I can give the row name as R2. I can give the row name as R3. Okay, so in that way you can create the row names, right? So let me run it. And maybe I wanted to give the call names as well. Okay, so call names of the matrix, and you know that there are 3 columns only, so you can give a column vector of length 3. Okay, just to give the name, right? So I will write here the column vector like C1. Okay, and maybe C2. Okay, it's up to you. Whatever the things you wanted to specify, you can specify, right? So now if I just show you mat, how it will look like, see here, right? So now this is being renamed. Okay, previously it was in this way, but now I just given a row names as R1, R2, R3, so it is coming as in this way, and I given the column names as C1, C2, C3, and now it is coming in this way. Okay, so this is the way how you can create a matrix. Okay, and how you can rename its number of rows and its number of column. Okay, so in that way you will create the matrix. Perfect. So up to this point, anyone have any question, any doubt? Okay, perfect. So yeah, please go ahead, Nusa.
Okay. So I realized that when you were trying to create, that
Mhm.
is the 17, the line 17.
Mhm.
Check line 7. The first one is like you used is a right assignment or left assignment,
Yeah.
and then
Mhm.
after data you use equal to. At what point do we use either of those?
Yeah. So whenever you are just passing the whole object, okay, whole object into a particular variable name, okay. So at that time it is up to you. You can use any arrow assignment, okay, any assignment operator. Maybe you can create a equal to operator. Maybe you can keep as a this operator, right? But inside, okay, inside this particular object, you will always use the equal to sign, okay, because this is up kind of this is actually running on some different concept which is called as function call by value. Okay, so this part I'll cover in our last of the basic R programming session. Okay, but up to that point, you please do remember, whenever you are calling anything, you are assigning anything inside the particular a function, like matrix is a function. Inside it, if you are assigning something to someone, okay, some variable, at that time you will only use equal to symbol instead of arrow symbol. But at this place you can use any of the symbol, maybe equal to, maybe arrow symbol. Okay.
So basically, outside the parentheses, we use the left assignment,
Yeah,
and
yeah.
then within the parentheses, we use the is equal to. I believe that is what you are trying to see.
Yeah, yeah, you can maybe you can also change it as well, like for example you can make it in this way. Okay, so this will also work, no
So let
problem
me.
at all.
Okay. Yeah.
Okay, so now you saw here I'm just passing with their per argument name. Okay, so I just write like data is equal to n row is equal to n call is equal to by row is equal to. Okay, right now I am doing all those, I'm writing all those things. Okay, because you all are in a very new in the programming. Okay, so always remember all those parameter names. Okay, so that if you remember all those parameters, then your mind will be open, and whenever you will do the programming, you will remember that what are those the parameter we are passing. Okay, but it is not necessary always just to pass all those parameters over here. Okay, so like for example, let me create a data. Okay, let me I created a data over here, like for example vector. Okay. Okay, let's say I has created as this data. Okay, values is 3, 336 and 339. Okay, maybe I can create more values. Okay, I just kept a how many values, 27 values. Maybe I can just check how many values are here. Okay, that is equal to this 20 values. Okay, so 20 values can be stored into the matrix into 5 cross 4 tables. Okay, means 5 into 4 is equal to 20, 4 is to 5, whatever the dimension I wanted to create, I can create. Okay, no problem at all. So let me create a matrix. Okay, I can show you, okay, how you can create a matrix in a very simple way, right? So like for example, matrix, exactly recalling the remembering the syntax, okay, that way I will just only call the data value over here, and that 4 comma 5 and true. Okay, now matrix is created. Okay, I did not call the parameter name over here. Okay, so I know that the first parameter what I am passing, this parameter is nothing but our data, so I just pass the data set over the data name over here. So second row, second is telling you about n row. Okay, this is telling you about how many number of rows you want in a matrix. Okay, so I want 4, so I specify 4, right? Previously I specify n row is equal to, right, but right now I did not specify n row option over here, right? Instead of that I directly call this one because I know this part. But for sure, at up to your level, you always specify these parameters. Okay, these parameters will help you out so that you can understand this part. The first value I just pass is nothing but number of rows, second value I just pass it number of columns, and the third value what I passed it over here is by row is equal to true. If I will make it as a false, then you can see here value will be changed. Okay, value will be changed, right? So previously value is coming like 32, 54, 67 in the row wise fashion, but right now this will come into the column wise fashion because I just make it from true false. Okay, so in that way you will remember. So it can be created in a multiple ways. How you wanted to create, you can create, but this always be a best practice just to use the all parameter names so that you will remember all those things and it would be easy, right? Perfect. So now this is the first way how you can create the matrix. Now let me tell you about the second way how you can create the matrix. Okay, so like for example, suppose you are having a vector called a, okay, and you are having values 23, 34, 56 and 67 and 89. Let's suppose this is having 5 values. Similarly I just create a vector of b, okay, 54, 54, 67, 89, 98 and 30, 43. Okay, 34. Let's say we are having third vector. Okay, third vector we are having, and in this vector we are storing the values like 12, 13, 14, 15 in this way. Okay, similarly I would have a, let's suppose fourth vector. Okay, 56, 87, 89, 0, 90, 67, right, in this way. So I can create a matrix by using these particular vectors. Okay, so suppose if I wanted to combine, I wanted to see like for example first value is 23, second value is 54, 12 and 56. So I will add all those things using c bind function or r bind function. Okay, so based on that I can create the matrix. So like for example r bind, okay, r bind function, and I will pass all those vector name over here a b c d. Okay, a b c d. So all those things will be bind up together and it will look like in this way, right? See here a matrix is being created for this particular vector. See, the first value is 23, 54, 12 and 56. This is the first column and this is the first row. So each row, each vector is treated as a row. Okay, so when you are doing r bind, creating a matrix based on the r bind, okay, so each vector will be created as a one row in the matrix, right? Similarly if you wanted to create a matrix which is one vector will be treated as a one column. Okay, so at that time what you need to do, you need to run the r cbind command. Okay, you need to create a cbind command. Now if you see here, so each vector, okay, what the vector we are having, this vector is coming as a one column. Okay, instead of one row, this is coming as a one column. Okay, so these are the two ways, okay, which actually you can use just to create a matrix from the vectors, right? So there are three ways you saw here. The first way is just to use a matrix function, and inside the matrix function there is a four important parameter you are passing. First is data vector, second is number of rows, third is number of column, and fourth is by row is equal to true or false. Okay, also you can pass dim names. Okay, dim names can be accessed using this particular command as well. Like for example you can specify the row names of the matrix, you can specify the column names of matrix. Okay, so in that way you can specify the names of the rows and columns, right? Another way of creating the matrix is just to combine all the vector using r bind function as well as using c bind function. When you are using r bind function, you are just setting up the rows. Okay, all the vectors will be comes as a rows, And if you are just creating a matrix using cbind function, at that time all the vectors which is participating just into the matrix, so one vector will be treated as a one column. Okay, so in that way you can create the matrix. Okay, perfect. So let me create a matrix and perform some operation into it. So let's suppose this is the matrix. Okay, so let's suppose this is the matrix I had created. Okay, so perfect, this is the matrix. So let me first check what is the mode of this particular data. Okay, it is telling me that this is a numeric matrix. Okay, this is a numeric matrix. Okay, so now let me check its type. Okay, how it is stored into the memory. Okay, so as I saw few minutes back, okay, into my iPad, that this will be stored in a two-dimensional way into the memory as well. Okay, so if I run this thing into the type of it will tell me that how by default it will be stored into our into memory. So memory will be take as a double value. Okay, now how it will, what is the shape of this particular data is, I can access it from the class. Okay, and in the class it is telling me that this is nothing but a matrix. Okay, this is nothing but a matrix, right? So in the memory it will store the values like as a double values. Okay, and their shape is nothing but is of the matrix type. And you saw that matrix is how it is stored into the memory. It is stored into the two-dimensional way. Okay, and one row and column wise the element will be accessed from this particular matrix, right? So similarly you can create the matrix of anything. Okay, maybe matrix of letters. Okay, let's suppose I will create the data as, for example, C, uh, in this way. Okay, A, B, C, D, E, F, G, H, and I. Okay, oh, sorry, in that way. Okay, so sorry, there is one more. Okay, I, B, C, D, E, F, G, H, I, check. Why it is coming? H, G. Okay, that, and length of that is nothing but this is of 7. Okay, let me increase one or more. G, H, I. Okay, this is the matrix I had created. Okay, so I will create a matrix of letters, right? How I can create the matrix of letters? So maybe a mat-l, I will just rename it mat-l, and I will pass this as a matrix. Okay, and I will pass the dat, and I will specify 3 and 3 and true. Okay, so it will create a matrix of letters, right? You can see here matrix of letter can be created. But if you create if you wanted to include any other data type, okay, so like for example if you specify here, let's suppose 1 2 3 4, okay, and 5 and 6, right? So 15 is there, so 3 into 5 if I will make it, right? So it will just make it in such a way that right now what is the length? Okay, it's 15 and 3 is to 5. Okay, it is telling me that and okay, perfect. And see here, these all numbers, what the numbers you are kept over here into this particular vector, this particular numbers are converted into the character format. Okay, why? Because you know that flexibility of the data types. Okay, so according to the concept of flexibility of data type, it is converting this character values into the numeric values. Okay, so this is the way how you can create the matrix. Okay, so if you are just creating a matrix or including a multiple data types of values into one matrix, so it will convert those data element into a single type of data values as per the concept of flexibility of data type. Okay, so always remember matrix is also a unique data type of values. Okay, unique data type of data structure, and this is of two-dimensional data structure. Okay, so this is the way how you can create the matrix and understand the matrix. Perfect. So anyone have any doubt up to this point? Anything? Okay, so I'm hoping that everything is clear to up to this point. Okay, so if everything is clear up to this point, let's move to the second concept, okay, which is called as how you will navigate, okay, how you will traverse into this particular data structure. How means how you will travel into this particular matrix, means how to get the element, how you will fetch a particular element into this matrix, okay, where this particular element is. Okay, so in that way you will just check those values. Just let me copy this particular matrix and specify some operation into this, right? So firstly let me create a matrix in that way, and yeah, so this is the matrix I had created, and this matrices look like in this way. Okay, so what I wanted to actually extract, let's suppose I wanted to check this value. Okay, I wanted to get this value out. Okay, so how I can do it? So this value is on the first number row and first number column. It means that this is nothing but on the 1 comma 1th position. Okay, 1 comma 1 means first row and first column position this value is. Okay, so how I will extract the value from this particular matrix? I will specify the first column, first row and first column. So the first element what I am specifying over here, this is called as rows, and the second value what is I am specifying over here, this is called as column number, right? So if you wanted to extract the first element, you will pass the first row, and this element is on the first column as well, so you will specify the first column as well, right? In that way you can extract the first element, right? You can see here the first element from this particular matrix is being extracted. Tell me about this particular element, how and what I need to specify to extract this particular element from this particular matrix. Everyone, please tell me. Put your answer into the chat.
So that one is four and four. Four on first row and then four another column.
Perfect, right? In that way. And tell me about this particular value. Okay, how I can extract this element. Anyone else apart from him? I'm talking about this element.
Is it the 87? Okay, so that is the second row,
Okay,
and then fourth
fourth column. Okay,
column.
now you remember it. Okay, that the first element what we are specifying into the matrix vector. Okay, so like for sorry matrix object. Okay, into the square bracket, the first element is nothing but indicator of rows, and the second element what we are specifying into this particular thing is nothing but a column. Okay, so in that way you can extract the element from this particular vector. Okay, perfect. So if this part is clear, okay, so I can just tell you about the updation part, that how you can update this particular data. So let's suppose you are capturing the data, and you wrongly input this value. Okay, and this value is nothing but 78, and at this place this is 87. Okay, so you wanted to change this particular value. Okay, so how you can change this value? So firstly let me identify this place value. Okay, so which place this is on the second number row and first number column, right? So this is nothing but on the place number 2, okay, and column number 1. Okay, this is the place value over there 87 is existing. Now on to this particular place, okay, I will insert the value, let's suppose maybe 90. Okay, let's suppose 90 or maybe 78, right? So I wanted to change this value from 87 to 78. So what I did, firstly I just identify its place value. Okay, so its place is nothing but second rows and the first column. So I just call this particular matrix and onto the second place and the first column. Okay, so second row and the first column, and on this place we just store the value as 78. Now this whole matrix will be automatically updated. Okay, so let me see whether this update is being done or not. Okay, and see here this update is automatically being done. Okay, so in the previous matrix what you were seeing, at this place there was 87, but right now this is 78. Okay, so in that way you can make the update into this particular matrix part. Okay, so any value you can change in any ways. Okay, perfect. So up to this point let me move towards the little bit more. Let's suppose you wanted to extract the this particular whole row, okay, or maybe the first column or the second column, and you wanted to extract the all column. Okay, right? So what you need to specify, mat, since all column all row is required, or maybe the first column you wanted to extract, so in the first column no need to specify anything into the row place. Okay, just to specify a space and a comma. Okay, and into this just specify the 1. Okay, so what it will do, it will extract the first column. Okay, see here 32, 78, 78 and 43, and here the first column is extracted 32, 78, 78 and 43. Similarly, if you wanted to extract the third column, okay, so third column means you will specify nothing. Okay, on the onto the row place, just to specify the comma and the third column. Okay, so in that way you will extract the third column. Third column is what? 67, 87, 87 and 65. Let me run it, see whether this is coming or not. See here 67, 87, 87 and 65. Okay, in that way you will extract the third row of this particular matrix. Okay, now third column, let's suppose if I wanted to extract any of the specific line, okay, a specific row. So what I will do here, so like for example, I wanted to extract the first row of this particular matrix, so I will specify 1, okay, and comma. Okay, no need to specify anything at the place of um, column, right? So in that way you will extract the first row, right? Similarly, if you wanted to create a sub matrix of this particular bigger matrix is, okay, let's suppose I wanted to create a sub matrix, and these six element I wanted to keep in my data set. Okay, so these six element is existing at which place, onto the column number, row number 3 and 4, and column number 3, 4 and 5. Okay, so in that way I will extract the element. Okay, so how I will extract, I will create a vector list 3 and 4. Okay, these are the column I want, these are the row I want, and column, how many column I want, 3 comma 4 comma 5, right? So let me run it and show you how it will look like. See here, a sub matrix is being created in from this particular bigger matrix. Okay, and this sub matrix will be only containing these six elements, like row number 3 and 4 and column number 3, 4 and 5. See here, it is coming 86, 87, 65, 76, 87, 65 and 76, here it is, and 65, 76 and 87 it is here, and it is here, right? So you can create a sub matrix by passing the index vector, right? So onto this particular place, on the row place, I just passed two values, row number 3 and row number 4. This is the index vector I just passed, and at this particular place I just pass index vector as column. Okay, see 3, 4 and 5. Okay, so I just pass three indexes over here so that I can extract the three columns, right? So in that way you can create a sub matrix from a bigger matrix. Okay, it is clear how you will specify the index vector. Let's just tell me, just to create a 2 by 2 matrix. Okay, let's suppose I wanted to create a 2 by 2 matrix, and I wanted to extract these four elements, 79, okay, 87. Remember, I wanted to create a 2 by 2 matrix from this particular bigger matrix, right? And I wanted to keep the element 79, 87, 89, 87. Okay, tell me what the code you will write. Again I'm repeating, I want a 2 by 2 matrix from this particular bigger matrix, and I wanted to include these two element and these two element. Okay, how you will write, what you will write code so that you can extract these four element only? Who wants to go first? Anyone?
Okay, I will.
The question again.
Sorry.
Okay, I will.
The question again.
So I'm telling
Can we
that,
do it?
yeah, I'm telling that this is the matrix I do have. Okay, this is the bigger matrix I have, right? And in this bigger matrix, I wanted to extract these four elements. Okay, and I wanted to create a smaller matrix, sub matrix from this bigger matrix, and I wanted to include only these four elements, these two elements, and these two elements. Okay, what the code I will write so that I can extract these four elements from this particular bigger matrix.
Okay, so you would let's say we are talking about the 79, 87, and then so you write yeah 30 was it line 30, line 2,
Okay, 2
line
comma 3.
2 and
Okay,
3.
okay,
The next one will be Which was
2 comma 3.
I'm just
Okay,
seeing the
2
wrong
comma
row.
3, right? So see here, right? I can extract the element. So these elements is existing. Okay, these element is existing onto the second row. Okay, and third row. Okay, because I'm just talking about these two element and these two element. So these two element is existing onto the row number 2 and row number 3, and where is it? It is existing column number 2 and column number 3. So if I will pass the index as 2 2 3 2 3. Okay, 2 3 means second number row and third number row. Similarly, comma second number column and third number column. Okay, so I will able to extract this particular smaller matrix from this particular bigger matrix. Okay,
Hello.
so
Hello.
yeah,
Hello.
yeah, please go
Instead
ahead.
of using the C function, can you just say math and then you introduce the square bracket and you use the colon instead of using the C function?
So here, because we are passing a vector, right, we need to pass the vector. So you need to create a vector over here, right? So you need to create a vector, otherwise you can specify in this way. You can specify in this way. In this way it will also,
This way.
right, this way
Yes, that's
also
what
it
I
will,
mean.
yeah. Okay, so because here we need to pass a vector, right? So vector can be of many types. One vector can be created using the C function, or you can say combine function. Another type of vector can be created into the colon function, right? Another type of vector can be created using the rep function. Okay, another type of vector can be created using the sequence function, right? So here, since I wanted to extract the values into contiguous position, okay, so I just pass here the 2 colon 3. So it will generate 2 3, and here also it will create 2 3. Okay, so 2 3 2 3 means it will create a 2 by 2 matrix, which will extract the row number 2 and row number 3, and extract the column as 2 and 3. Okay, and it will give a sub matrix of size 2 by 2 over here, right?
Right.
Yeah, yeah, go ahead, anyone.
Yeah, I will please. I want to ask a question. I don't know.
Yeah, please ask your question.
Hello. Uh-huh. What I want to ask is that in case maybe you have a lot of matrices, you've created a lot of matrices in R, but you want to extract a matrix from a particular matrix. How will you tell R that this is the kind of matrix I will want to extract that matrix from? I don't know whether you get a question.
No, no, I can't get your question, Richard. Maybe come again. Sorry.
What I want to what I want to say is that maybe you've created a lot of matrices in R.
Mm-hmm.
Maybe like for example, what we've done here, we've created matrix, the first matrix, and then the second, another matrix again,
Mm-hmm.
and then another matrix, say maybe three consecutive matrices,
Mm-hmm.
and then you want to extract a matrix from a particular matrix you've created. How will you tell out that this is what you want to do?
Okay, so I guess your question is related to, like, for example, here the bigger matrix we are having. Okay, so there's a bigger matrix we are having, and how you will extract the smaller matrix from this particular matrix, right?
Ebo. Ebo.
So this is matrix one, right?
Mm-hmm.
This is one.
Okay,
Then in the same way, we've created another one
okay,
in R, and
okay,
you've created another one again.
okay.
But you want to extract a matrix from this particular matrix. How will you be able to tell R that this is a particular matrix I want to extract my matrix from?
Maybe I'm not clearly getting your questions. That is why maybe I'm not able to answer. If anyone is
Okay,
Ebo.
clearly understanding, please
Yes,
answer. Yeah.
I understand what he's trying to say
okay.
is you
So
have
I think what he wants to say is that he has three different set of matrices,
Okay.
where the first matrix A, second B, and then third C.
Okay.
And then he wants to extract a smaller matrix from one of them. But the function or the code to enter doesn't include the name of a specific matrix. It's just math. and then into brackets
Okay, okay,
2
perfect.
1.
Okay, perfect. So every
Yes.
time,
So
like,
how do you know the
yeah,
exact?
yeah, yeah, got your point. So every time, like for example, how many
Yes,
matrix
yes,
you will
yes.
create, right? It is not necessary. Like for example, I am creating this as a mat name. Okay, so you can create in any ways. Okay, like for example, as per your naming convention, whatever the matrix you wanted to create, like for example, matrix A, matrix B, matrix C. Okay, so if you wanted to extract the element from A, you will specify in this way. Okay, maybe rows and column. Okay, whatever the row you wanted to extract or column number you wanted to extract. Similarly, you can pass it over here B. Okay, so and in from the B matrix you can specify the row and column. Okay, not necessarily always you will specify the mat over here. Okay, because I just write this as a mat matrix. Okay, that is why I'm just extracting the element from mat just for your demonstration. Okay, whatever the matrix you will create, you will keep the different names over here, and whatever the element you wanted to extract from each and every matrix, you will specify the rows and columns corresponding to that particular matrix. Okay, I hope I'm able to answer your question.
Okay, so it means that the math is not actually a specific function in R.
Yeah,
Is
yeah.
that the
This
case?
is just a variable name. Okay, matrix is
Okay.
basically a
Okay.
function. Okay, matrix is a function, R bind is a function, and C
Yes.
bind is a function. There's a three function I used, and mat I just name as a matrix name, just a variable name. Okay, I just specify this as a
Okay.
variable name. Okay, nothing else. Mat is nothing. It can be of anything.
Okay.
Okay, so like
Thank
for
you.
example, if I write over here instead of this particular thing as a mat, okay, I can keep the name like for example is. Okay, so this is the
Abby,
is matrix
Abby.
now, right?
Okay, please. But in trying to type the math in R, you see that it gives you a suggestion,
It is giving,
signifying
yeah,
that
it is giving me
it is a
suggestion.
function.
Yeah, it is giving me suggestion. But for sure, you can see over here, right? So you can see here, this is nothing but our data values, right? So it is giving me suggestion like if I will just click over here that tab, okay? So if I give here tab, it will not do anything, right? But if I will type it little bit more, okay? So if I give the tab, then it is typing it into the full form, okay? So it is just a hint it is giving,
Uh,
okay? The first hint is basically this is for our data set. Okay, what the data I had created, this is the hint for that particular part, and this hint is just a hint that you will type further to get something, right?
okay, okay,
Got it?
okay. Thank you.
Okay, perfect. Now, how you can update into this particular matrix? Okay, so as you saw, like for example, just for calling a particular position and replacing. But suppose if you wanted to add anything into this particular matrix. Okay, let's suppose this is the data values you are having. Okay, this is the data values you are having, and this is the matrix you are having. Right? In this matrix, let's suppose if you wanted to add a new column. Okay, if you wanted to add a new column, okay, so what you need to do just to add a new column, right? So just for adding the new column, right? So what you need to do, the new column will come here, okay, onto the sixth position. It means that the sixth column will be created, right? So at that time what you need to do, you need to remember one most important thing, that if you wanted to add a column, then in this particular column there will be total number of four rows. Okay, like for example, since here are four columns, right, four rows are there. So whatever the column you wanted to add, this column will also have only four rows, right? So what I will do here, so I will create like for example a vector, okay, element like for example a, and I will keep four rows over here, 34, 43, 65, and 67. Four rows are here, right? So I will use, what I will do, because I wanted to create a new column over here, right? So new column I wanted to create. So what the function I will use? I will use age is equal to, okay, cbind cbind, because I wanted to I just combine and create a new column. So I will use column bind function, right? So I will pass the matrix, previous matrix, and this particular vector, right? In that way I can able to create a new row. See here, a new row is being created automatically, right? So 34, previously there is a rows are there. Okay, right now new previously there is a five columns, but right now you can see here one, two, three, four, five, and six column is being created, right? So in that way you can see here I can able to add a one column. Similarly, if you wanted to add a new row over here, okay, so if you wanted to add a new row, right, at that time you need to remember that how many columns are there. So these number of elements should be there into the new row, okay. So like for example, how many rows how many columns are there? So there are 6 columns. So in this particular vector, how many values will be? 6 values: 23, 43, 54. In that way you will pass those elements, right? So this is the elements. Now since I wanted to create a row, so I will use rbind function, okay, rbind function, because I'm just going to do a binding of rows, right? So I will use this matrix and this particular vector, and I will add it, and you can see a new row is being added, right? So similarly you can add a new column, and similarly you can do a one add a one row, okay. In that way you can do the update part, okay. Now why we are doing so many things over here, right? Why we are doing these addition, the subtraction of the matrices, element extraction, okay? Why these are the important thing? Why data structure of matrix is very important over here, right? So you need to remember the use of this particular data structure. Like for example, when you are doing a complex modeling, okay, at that time you will have a complex matrix solutions, okay. So you know that just to solve 2 by 2, maybe you are having two equations, it is easy to solve, okay. Two equations of two variables, right? So you can easily solve those equations. But if you are having three variables, three equations, it will be little difficult to you to solve, okay. But if you are having a four variables and four equations, okay, it is little hard to you to solve. Imagine if you are having 1,000 rows and 1,000 columns. Okay, is it easy to solve? No, it is not easy, right? So solving the equation is a very difficult problem. So matrix actually helping you out to solve the problem. Okay, just to solve the equations, right? So just to solving the equation, matrix is a very helpful thing. Okay, that is why we are learning over here the matrix concept. Okay, and also, okay, so just to store the data values which is of two dimensional, you will use the matrix data structure, okay. So this is the use, okay, why you are learning matrix part. Also sometimes when you are dealing any statistical modeling activities, sometimes you are getting output in the form of matrix. So using this particular method, like how you will extract the sub matrix from this particular data, or a particular element from this particular matrix, okay. So that is, these are the few examples how you can extract the element from this particular matrix, okay. Yeah, please go ahead.
Well,
Yeah.
you see, when you called for the first line, row 87,
Okay.
age, then you give the command matrix and so and so. And then you wanted to add another column, right? So you created A, which is you concatenated it. You created A 34, 43, 65, and then 67.
Mm-hmm.
And now to combine, set each, then you did C bind, right? C bind, and you add each, and then you added A. Instead of putting the age, it means that you've already stored the command matrix that 45T to age. That's how come you placed age over there for row 80, row 89. Instead of putting the age, can you just put matrix DAT that 45T instead? Would it produce the same result?
No, no, because here what we are doing, we are having already a matrix, right? And in this particular matrix we wanted to add a new column, or we wanted to add a new row, okay, because matrix is already being there, right? So in a existing matrix you wanted to add or subtract something, or maybe add a column or add a row something, right? So since matrix is already been there, so you will apply a rbind function which will just add a matrix, with matrix a single column, and with matrix a single row, okay. So using the cbind function, in the existing matrix you are adding a one column, right? So you will pass a matrix and a new column, okay. And if you wanted to
Yes.
add a column, a row into other matrix, so you will specify the matrix and this particular row, right? You need to do in this way only.
Okay, so the arrow sign, the assigned arrow, the backward assigned arrow,
Hmm.
it does not necessarily mean equal to, because if it's, that means that in as much as you are saying age for 87, age, then a backward assigned arrow matrix DAT 45T,
Mm-hmm.
it does not necessarily mean that age is equal to matrix DAT, but age has rather been assigned to that, right?
Yeah, 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 yeah,
Because
yeah,
I was assuming
yeah.
that if you, I
Mm-hmm.
was assuming,
Okay, yeah, that
I was
why
assuming
yeah,
the,
why we are doing here, because in the age matrix we are updating this particular matrix, right? So again I'll get back this particular matrix, this particular named as a age. Okay, why I just put it this again, this same variable name, because I wanted to create a age matrix with addition of a new columns or new rows. Okay, so I don't want to change the name. Maybe you can change it, no problem at all, but it will perform the operation into the age column part, age matrix particularly. Like, so for example, if I will rename it, okay, so let's suppose if I will rename it and make it as a sorry, maybe I will rename it, and let me firstly create this matrix, and yeah, let's suppose I just did this way, and I just rename it, right? So it will be renamed, okay, no problem at all, right? So this will be renamed, right? And similarly, if you wanted to a new column into the previous matrix, like for example this matrix age, okay, so here there is a more column is there, because here in the age I wanted to update, right? So in age, what, how many number of rows are there? Okay, we are having number of columns as 5, so here I just kept the number 6, so I will remove once, it will make it 5, and I can add in this way. Okay, so as 2, right? So it is up to you that if you wanted to update this part, okay, just keep the variable name same, and if you don't want to update this part, keep the name as different. Okay, it's up to you at all.
so what will happen if I type, let's say I type age, right?
Mm-hmm.
Then I assign, right, instead of age. So let's say type age for me, age, then um, no, like a new line, that's in line 94. What would happen if I type age,
See here.
age, then
Mm-hmm.
backward? No, no, not that. I want to, like, I'm not done with the sentence. Age, then backward assign, then
Mm-hmm.
I combine, and I do C bind, right? And I put C bind, and I put matrix,
What matrix?
matrix DAT, matrix,
This one?
matrix. No, just matrix, the matrix, type matrix.
You wanted to create that matrix? Okay.
Yes.
So this you wanted to sell this one?
No, if I copy, I want to copy the 87, the command for 87.
Okay, okay, okay. Okay, this one you
No,
wanted to.
from yes, I copy this one,
Okay.
right? And I put command, I put
Okay, yeah, yeah. In
A.
that way you can do. Yeah, you can do it. Okay, no problem at all. Like for
No,
example
A
here,
instead of
how?
the,
Mm-hmm.
no, you empty now to
5 is there, and B
yes.
is how many?
No, it should be okay.
Number of rows?
No, you can put A rather instead of B.
A?
Yes, yeah,
A.
A.
Okay. So A is of length 4. Okay. So there's a 4 rows are there. Okay. So there's a element of 4. So firstly, what it is
Yes.
doing? It is creating a matrix, and in this particular matrix, a column is being added. Okay.
So it doesn't mean that it's so it will create the matrix DAT for you and add the A column, right?
Yeah. Yeah. Yeah.
That's what I was saying. That instead of just saying matrix, let's instead of just saying H C bind, then you put A and then the other matrix. When you copy the actual code from 87 and you paste, it should give you the same. That's what I was saying.
Yeah, miss, yeah, it's up to you. Like it's up to you the what the purpose you are serving for, right? So you can update in any ways, right? So you can update this directly into the data set level. Okay, you can create like for example you can make some changes over here. Like for example you can add your data over here, then pass into this matrix. Okay, no problem at all. But I am just talking you about updation of the matrix part. You are already having a existing matrix, and into this existing matrix you wanted to add something new, right? So at that time what the operation you will perform, I'm talking about that part, right? So like for example here you are seeing a very small data, that is why you are making some changes over here, right? So you can change a to b, b to a, a's, and multiple things you can do. But imagine this situation into thousands of rows and thousands of columns, right? So imagine in that way it is very difficult to manage at that time. So at that time what we will do, we will just use the R bind and C bind and perform some operation. We are not changing into the matrix level things, okay? So here what I am assuming is that matrix is already being there, and we are just making some updation into that particular matrix, okay?
Okay.
Yeah, perfect.
All right.
So yeah,
Thank you.
this is all about matrix part. So maybe yeah, next data structure we will cover in maybe tomorrow's class. Okay. So because we are running out of time, so thank you so much, and it's really a very nice interaction today we